Welcome to Brain Vision.
So we have a pulley, a double pulley, and one of the circles has a radius of B, of C, and one of them has a radius of B. So we have a P force being applied here, and we have a force that we're going to call Q, the tension force being applied here. So we also have a mg being applied to the center. So let's do our impulse momentum theorem. Let's analyze our impulse. Well, first let's list our givens. We have RC is equal to 0.150 meters, RB is equal to 0.080 meters, and our radius, centroidal radius of gyration is 0.100 meters. Additionally, we have the pulley has a mass of 3 kgs, and that the pulley force is 24 newtons. So for A, we want to determine the velocity after 1.5 seconds. So let's do that. First thing we need to do is use our impulse momentum theorem, or IMT, and that states that our change in angular momentum is going to be equal to the impulse. So we have a 0 initial angular momentum plus an impulse of p times the radius of b plus rc, since that's the distance from this point around which the rotation is occurring. So rb plus rc, and momentum. So this is the moment. Now we need to multiply that by the time to get our impulse. So this is one of the impulses being provided. Next, we have the impulse being created by mg. So this is a distance rc away. So this is going to be mg t times rc, and this is all equal to I omega plus mv rc. So this is the combined translational and rotational momentum of the system. So now we're going to solve. So we're going to expand this out a little. So 0, now we have P of RB plus RC times T minus MGT RC is equal to MK squared omega plus MV RC. But you'll recall that V is equal to omega times RC. So we can rewrite this as M RC omega RC. So now we have omega is equal to PT RC plus RB minus MGT RC all over M K squared plus RC squared. So if we plug in all of our values for that, we get P is equal to 24, T is equal to 1.5 times these individual radiuses, which are 1.5 plus 0.08 minus 3 times 9.8 times 1.5 times RC, which is 0.15. And this is all over 3 times k squared, which is 0.1 squared plus 0.15 squared. So this gives us an omega of 17.077 radians per second. So for part A, our solution will be V is equal to omega times R, so that's V is equal to 17.070, this is RC, so 0077 times 0.15, and that gives us a V of 2.55 meters per second. Excellent. Now on to part B. So for part B, we're going to analyze the linear components of the linear momentum. So we have 0, which is the initial linear momentum, plus pt minus mgt plus qt is equal to mv. So we have q is equal to mgt we have mv over t minus mg, or plus mg rather, minus q minus p. Oof. Okay. So this is going to give us, this is 3 times 2.55 over t, which is 1.5, plus 3 times 9.8 minus 24, and that gives us a tension force of 10.53 newtons.